So here is a tricky one. I think this one's actually kind of fun to look at. First, I think it's important to take a look at. Let's take a look at a power series representation of some other function, 1 over x to the fourth plus 16. I'm going to change this around, get a power series representation of this, because I know that f of x, and you got to be a little bit clever here, is equal to x squared times, is equal to g of x times x squared, right? Because that just puts a x squared on the top. So let's find a power series representation of this. This is the same thing as 1 over 16 times 1 plus x to the fourth over 16, right? And then I have, that's just 1/16 times 1 over 1 minus negative x to the fourth over 16. So we have that. We have our 1, 1, and minus. Those were the things that I needed, and then some other stuff in there. So I can go straight to my series representation. And I'm going to have a 1/16, right, from that. And then times, we have negative x to the fourth over 16, and that's going to be to the n. So I'm going to simplify this now. That is the same thing as n equals 0 to infinity of, well, that would be negative 1 to the n power, because that's the negative there, x to the 4n, okay, over 16 to the n times another one, so I can say plus 1 there. So that's my series representation for g of x. But I know that g of x times x squared is going to be f of x. So I can say f of x equals x squared times this. Well, this is just going to be things added up together, all up. And if I multiply everything by x squared, I would be distributing it to all those things. So I can actually move this on the inside, because it doesn't have any n value. So it's not going to change. It's just going to be the same as multiplying it on the inside. So this is the same thing as the series times the x squared on the inside. But those have the same base, so I can actually rewrite the whole entire thing as the sum from n equals 0 to infinity of negative 1 to the n times x to the 4n plus 2, right? Because that's what that is, all over 16 to the n plus 1. Isn't that neat? And now my radius of convergence. That is still the interval of convergence for g of x. So we actually have to figure out the interval of convergence. Oh, I never finished the parentheses there. Of g of x. And then that will be the same as the interval of convergence for f of x. So, what is the interval of convergence? We know that, I'm going to do it in red, negative x to the fourth divided by 16 in the absolute value has to be less than 1. Multiply by 16, the negative will go away. X to the fourth, I guess we don't need the absolute value either, less than 16. So what can that be? X would be, what, negative 2 to 2, right? Because 2 to the fourth is 16? Yes. And if you put a negative, yep, that'll work. So the interval of convergence for f of x is going to be the same as for g of x, otherwise we wouldn't be able to do this. And it would be from negative 2 to 2. That's a fun one. Oh. So when you even when you have x squared on the top, a trick to do is to get rid of that and just know that fact and make up another one. So that was a fun one. Okay, good.